of 03 and 04, and this has 05. And so you think that I want Roshan to access the elements present in this locker. So how will I inform him? So basically, I would say, hey Roshan, can you just get me whatever items are there in locker 3? So what happens is that basically Roshan will go to this location or address 03, and will open this door and access whatever elements are present. In the same similar way, we have arrays where we have elements that is 8, 9, 10, 11, and 15, and each element has an address or index 0, and it always starts from 0. So now if I want to access an element that is at let's say index 2, I will just say like let we name this array as r. I will just be like, and whenever I say this, I will get the value 11 that is present at that location. uh, so as you guys can see, each locker has a fixed position, a unique number. A unique number basically means the address, which is unique, and a single door you can open to access what's inside it. So that's the main concept. So whenever you use the index, that is the location of the element present in that array with the array name. Whenever I say array 3, then I will get whatever is present at that location. Currently, in this case, it's 12. Yeah. So I guess you understood this, and this is like the most intuitive way, and you can visualize it how things work with the example of a locker. And coming to the next topic, that is the main thing that we are learning today. That is, what is a two-dimensional array? Okay, a two-dimensional array is where each element is an another array. Okay, so let's go to the drawing sheet and understand carefully. So we know that this is a single one-dimensional array slash vector, and I have elements. Now, instead of having numbers or anything as elements, what if we have elements as an another array of one dimension? So in this place, I have another array of dimension. In this location or index, I have an array of another dimension, and so on. So basically, what does two-dimensional array basically mean is that it is a array where each element is an array itself. So it's basically array of an array. And if I want to give you a best analogy where you guys can understand it in a more detailed way, is by giving an example of an hotel, where we have this hotel, and this is kind of like a grid, like as you guys can see, and this represent a single row, and each row has a new individual array. uh, each row has a new individual array, and like that we can have as many number of array we want. So this is basically I have zeroth row, and it has an array of three elements, and I have first row which again has an array of three elements, and I have a second row that is having an again the array of three elements. So coming to like coming to the things where you guys can see this like every day, like you guys can see the chessboard which has the same grid like representation like this, or coming to an Excel sheet where you have rows and columns. So some 2D array is just like that. It's just the way you say in an Excel sheet or in a chessboard or in a 2D or in any other places where you can find this reference. And coming to how we are actually accessing the elements in a two-dimensional array. So it's same way as one-dimensional array where we specify its index, but here we are also specifying another index. This index represents its location in the array of array. Okay, so if I put it in other words, or if we use an analogy here, that is a hotel. So we know that hotel has different floors. Like this is the a first floor, this is the second floor, this is the third floor. Now you say that you and your friends are hanging out in Goa or Maldives, and you go to a hotel and you want the best view, and that is present at the top floor. So if you go to the receptionist and you say like, "Hey guy, hey bro, I want a room in the third floor of the hotel," and then you will also specify in the third floor which room you want. Either you want the first room or the second room or the third room. Let's assume that you want the second room. So you will basically say the receptionist that, yeah, go to the third floor, and in third floor I want the second room. This is it, guys. So basically you're just using this concept to access an elements in a two-dimensional array. You think, if I want to access an element, basically, okay, now if we just translate this whole hotel scenario into a grid like representation, so basically this means I want this a room, and how will I say the receptionist? I'll be like, hey receptionist, uh, give me in go to the third floor and give me the hotel present in the second room. And since we are following zero index, so basically we will subtract one digit from each of the row and the column, and basically we will have this. So basically it will be 2 comma 1. And coming to how we can access the elements, you can basically just write this r 2 comma 1, where basically this represents the row and this represents your column. Yeah, this represents your column, and each value two-dimensional array is, as I said, located using the name of the array, then the row and the column. And as it's written here, the first index chooses the row and the second index helps in choosing the column. And this is how you guys can understand the whole concept. Like, let's take some more examples where you will get better understanding. Uh, if you guys can like think more, it's basically just like how you guys do the coordinate geometry, where you have a graph and a grid and just want to locate the points. So let's assume that this is a zeroth floor, this is first floor, the second floor, and this is zeroth column, first column, and the second column. You think I have a element 10 present in this location. So what would be its coordinate representation? So basically it would be the row and the corresponding column. So basically its location is 2 comma 2. And if I want to access the element present in this location, so I'll just basically write this command, where this represents the row and this represents the column. And just imagine that if I have another element 5 comma 5, so basically I would just write 1 comma, sorry, I'll just basically write the row and the column, so that is 0 comma 1. So in this way you can access the elements from the two-dimensional array. I hope you guys are following me and have no doubts. Let's check if any of you have any doubts. Yep. Do you guys have any doubts? Let's get a quick check from you guys. Just reply a yes or a no. Yeah, guys, I'm waiting for you. Let's have some high energy and make it an interactive session. Yeah, no doubts. I hope you guys are understanding it well. Yeah, let's continue. Yep. So we have learned what is basically a two-dimensional array and how we can access the elements in a two-dimensional array. And coming to the declaration part, C++, how we declare a two-dimensional array. So basically, if we just want to declare an array, two-dimensional array, we just basically write this command. We will say vector int mat. Okay. So let's have a clear breakdown of what this code actually mean. So basically, this is the name of my 2D array. Uh, Okay, and what does this represent? Basically, what I'm saying here is that you are basically saying that let's make a vector. We are not specifying the number of elements currently, but just imagine that we have n elements here. And what does this line mean? Is that basically we are saying that the elements of this vector is again another vector, and this vector, like let's have a better pictorial. So basically we're saying that the elements of this vector is again storing a vector, and the data type that is being stored in this vector is integer data type. So basically what I'm saying here is that we are having a vector data type, and inside this vector data type, each element is an another vector data type, and that vector data type is basically storing an integer data type. That's it. That's as simple as that. And this basically is the name of that vector. So here, what we have done is that we have just declared an array. I mean, declared a two-dimensional array without specifying a row or column. It's just an declaration. That's it. But here, we are basically initializing a, a vector of given dimension. Okay. So what we are basically doing that we are basically declaring the number of rows that's present in a two-dimensional array or vector, that is three, and number of columns. And what we have written is vector of vector. So this basically means that a vector is storing another vector, and its data type is integers, and and the name of the vector. And coming to this new thing that we are seeing here. Okay, let's go to the whiteboard and have better understanding of what's happening. Yeah. So let me erase the previous contents. So it's always important to have a very good understanding of what's happening in each line slash word of your program. So let's rewrite them. So what we have done is we have said integer rows is equal to 3. And for the sake of simplicity, let's assume that the columns are 3 as well. So what I've written is that vector int matrix rows slash um, vector int call. So basically what I'm doing is that let's go from inside to outside. So basically what does this line mean is that we are making a 2D vector where the number of columns present in this vector is actually this call, which we have assigned as 3, and this represents the number of rows, that is 4. So basically it boils down to this. uh, Sorry, this is actually 3. Yep. So basically what I'm saying is let's make a matrix 2D vector which will have 3 rows, and each row will have a vector whose size is 3. So if I say again, we'll have a mat with 3 rows, and each row will have a vector whose size is 3. That basically means we have each row basically has a vector, 3 sized vector. So that's how you initialize a vector of given dimension. And another fun fact is that whenever you write this code, you will always get a, okay, oh my god, yeah, let's erase this. So basically whenever you write this code, you'll always get a matrix that is already initialized with zeros. So here if I say a row is equal to 3 and column is equal to 3, so basically you will get a two-dimensional vector slash array of 3 cross 3 dimension, and each element of this matrix is assigned to 0. So that's how you create a matrix of given dimensions, and this is how you generally declare a matrix in C++. Uh, so I hope you guys don't have any doubt on how do you declare and initialize an array. Let's get a quick responses. Hi guys, are you guys in the meet? I see that there are 54 people and yeah, there's no response. Let's have some energy and I just want to know if you guys are understanding everything that we are covering now. Come on, guys. Yeah, yeah. Good job. Hope you're understanding it. Okay, come on. Let's move to the next topic. That is taking the inputs from the user in a two-dimensional array. So basically, I know you guys have learned from the previous lectures how you guys generally take input for a one-dimensional array, but in two-dimensional array, it's not completely different. You just have another for loop. That's it. That's as simple as that, and there is no huge rocket science behind it. So basically, let's look at this code. So you're basically defining rows and columns, and you're taking the dimensions from the users. Let's take its three rows and three columns, and we are initializing a 3 cross 3 matrix. That's what this is, the same code that I explained previously. So basically this will make a 3 cross 3 matrix of and all the elements are initialized to 0. So we are using this for loop. Okay, so let's understand step by step. So basically this for loop basically helps us to access each floor. If I take the analogy of my hotel, so this for loop basically helps me in accessing each floor of the hotel, and this for loop basically helps to access the rooms present at that floor. Um, so like let's have a small dry run where you guys can get a better understanding of what's happening present at that specified floor. Yep. So this is basically the way you take input. And as I said in the previous slides, that this is how you access the elements present at that coordinates. So let's have a small dry run. Okay, let's have a for loop, and I is equal to 0, I less than 3 because that's the number of rows. And let's have another for loop that helps me in accessing the number of rooms present at the given floor. Yep, so I'll be like cn. Yep, so let's initially construct a matrix, and each element of this matrix will be assigned, and let's have this indexing so that it will help us in better navigation. So initially let's do a small dry run when I is equal to 0. When I is equal to 0, the control runs inside this for loop, and we will have j is equal to 0 as well. And so basically that means we are basically accessing the element present at 0 comma 0 location. So what we are basically doing is that we are asking the user, hey user, just say me what value you want to store at the 0 comma 0 position. Let's imagine that the user says that I need to store 21. So basically we will store 21 in this location. And in the same way this continues, we will have j is equal to 1. That means we will have 0 comma 2. That basically means at the 0th floor, sorry, basically this would be 1. So basically that means that at the ground floor or the 0th floor, in the first room, what would be the value stored? So it will basically, let's say the user says 30. So you basically store the value 30. And the similar way, this loop runs till 2, and this, and we will fill all the rooms in the ground floor. Then we again come back to the initial for loop. Now it will be changed to 1. So that means basically we are now filling the first floor. And again, we will have this for loop that will run from 0, say, to index, and we will keep on filling. Let's say that this would be 60, this would be 70, this is 90, and so on. And we will keep filling, and we are done with the first floor. Then we'll again move back to the outer for loop. Now I value will become 2. That means you are basically filling the second floor. And we have this the inner for loop that basically helps us accessing the rooms present at the second floor, and we normally fill them with the elements like this. Let this be 130. So in this way, this code helps us fill the elements of a two-dimensional matrix. Yep. And next, coming to the one of the important concepts, that is indexing and special patterns, and that will be used in navigating in a two-dimensional array. So one of the most important concept is the concept of diagonals, that is primary diagonal and secondary diagonal. So let's look at this diagram. So what does primary diagonal basically mean? So it basically means all the elements present at this diagonal. So basically this is a primary diagonal. And secondary diagonal basically represent this diagonal in our matrix. So this is our secondary diagonal. Okay, so let's take another example of a matrix and try understanding the concepts of primary diagonal and secondary diagonal in a much more depth. So let's fill this 3, 10, 15, 9, 8, 6, 13, 18, and 19. So basically, I know that this is my primary diagonal. So let's first take the location of 3 in my 2 cross 2 matrix. So basically, this is present at 0, comma 0 location, and my next diagonal, that is 8, it's present at 1, comma 1 location, and my last diagonal from the primary is 19, and it is present at 2 comma 2 location. So as you guys can see that there is a simple pattern that's occurring in the diagonal. So that is the row and the column indexes are same for the primary diagonal. So if I write it in a generalized structure, so basically I can access the diagonals of any matrix just by writing this line. So as I said in the as we saw that in this example, 3 is located at 0, comma 0, 8 is located at 1, comma 1, and 19 is located 2, comma 2. So basically we got to know that for all the diagonals there is a simple pattern that the rows and the columns are equal. So we can use the same thing and just have a single iterator that is that so that we make sure that the rows and columns are always same. So basically, whenever I write this code, basically I'm actually accessing the diagonals of a two-dimensional matrix. And coming to the secondary diagonal, let's start marking down their locations. So this is my secondary diagonal, and my 15 is located at the coordinates 0, comma, and my 8 is basically present at the coordinate 1, comma 1, and my 13 is present at the coordinate 2, comma 0. So as you guys can see that, yep, there is yet another pattern in the locations of the elements of the secondary diagonal. So basically, as we go from 15 to 13, we see that the row is increasing and the column is decreasing. Now, if I want to represent this in a more generalized term, I can basically write like this. So let's keep this increasing pattern as I. That is, we'll take the row as I. And how can I represent this this decreasing pattern that is coming in the columns? So basically, I can just take the number of columns that is initially present. So here we have, so since this is a 3 cross 3 matrix, so basically we have 3 columns. So basically, 3 columns and 3 rows. So basically, I can write 3 minus I minus 1. Okay, now I have written this. Now let's test it by again putting the values of I from 0 to 1 and see that we getting this same coordinates or not. So let's put I as 0, then we will get R of 0, and 3 minus 0 minus 1 is actually 2. Yep, we got the first coordinate. Let's move I to 1. Now 3 minus I is 1 minus 1. So basically it's 1. Yep, boom. We got another the same coordinates as this, that is 1 comma 1. And the last coordinate when I is equal to 2, we got 3 minus I is 2 minus 1, that is 0. And yep, we got the same indexes again. So basically, this is the formula you guys can think that we will use to access the secondary diagonal elements. And coming to the point of why we are doing minus 1, basically we are doing minus 1 because we are using a zero index. So zero index basically means that our array starts from zero index. If it's starting from 1, then there is no requirement of doing this minus 1. It's just 3 minus I. But whenever we are doing this zero indexed, we always have this minus 1. So that I will generally answer your question of why we are using minus 1. This is actually a pretty important concept, and I hope you guys understood this formula of primary diagonals and the secondary diagonals. Yep. Let's see the Josh in the chat. Just say that you guys understand it or not, and I'm open. You just can ask me any doubt, and I'll just reply. Can Yep, it can be. Yep, that's completely fine. We can have an 2D array of 1 comma 2 and 1 comma 2 comma 3. It's completely fine. For our sake of simplicity, we are just taking a square. Where is my pen? For the sake of our simplicity, we are just using a array where we have both rows and columns, because since you guys are in the like learning phase, this will be much more helpful. That's obviously true that you can have a matrix like this, or you can have a matrix like this. uh so this is like similar to just like the two-dimensional matrix that you guys are learning. And in your first years, I mean, for the first years, they will be learning matrix. So it's just like that. So you guys can have a matrix of any of these kind. Yup. So this formula basically helps us get the secondary diagonal elements, and yep, we can get it in a single loop. To get the primary diagonal elements, we just write array of brackets I and then the brackets of I. Is your doubt solved, Samarth and Shivam? Or you need, yeah. What about Shivam, bro? Is your doubt solved, or you need a better explanation? What about are you other guys present in the meeting? Yep, clear. Yeah, good job that you guys are attentive in the sessions. We are very happy about that. It's valid for, yeah, it is valid for both square and non-square matrix. So basically, if we consider a non-square matrix, that so basically, if you guys, okay, like we have a specific example in the future slides where we are going to show. So I'll just come to your doubt at that slide. Yep. So now I'll not miss on that doubt, and I'll show you how it is valid for both kind of matrices as well. Now moving to the next concept, that is the corner representation of the corner. So basically, We have the top left, the top right. The top left is basically 0 comma 0. The top right is basically 0 comma the number of columns minus 1. In this case it's 5 minus 1, that is 4. And the bottom right is again 4 comma 0, and the bottom right is 4 comma 4. And coming to the boundaries, boundary elements basically mean all the elements present in at the boundary rows and columns. So this is the top boundary, this is the bottom boundary, this is your left boundary, and this is your right boundary. So these are the concepts of the corners and the boundaries. And coming to the traversing, yep. So in this slides, I will be basically saying how you guys can, yeah. So this is the example where you have a non-square matrix, and our formula of diagonal matrix will work on this as well. Yep. So coming to the concept of indexing and pattern, where we are gonna learn different types of traversal. So basically we have completed the indexing part. Now we will do the traversing. So what do you guys mean by traversing? So traversal basically means a systematic way of visiting all the elements present in the matrix. It's very important for printing, searching, or processing the elements that is stored in the array. So basically it's a systematic way of accessing each element of the matrix. So there are different types of traversal, and the first traversal that we're going to cover is row wise traversal. So basically, what we are doing is I have split all the traversal into parts. The movement that we are going to follow and the mechanism. So the movement is basically what we are going is from. So basically, we will first go to a row, and in that row, we will move from left to right, accessing each column one by one like this. So basically, I'll be at my first row, then I will print 1, then 2, then 3, then 4. I'm done with the first row elements. Then I'll move to the next column, that is 1. Then I will access all the elements, that is 5, 6, 7, 8. Done. Then I'll go to the second row, that is, and I'll start accessing all the elements 0, 10, 11, 12. Then in the same way, I'll do until all the matrices are covered. So the mechanism that we are going to follow here is that we have a outer loop that iterates to the rows and inner loop that will iterate to the column. And analogy that you guys can use is it's like reading a book. So basically, you will open a page, then you read like this, then next line, the next line, next line, next line, complete the book, then move to the next page. So that's the simplest analogy that you guys can use for understanding the row-wise traversal. And the next type of traversal is column-wise traversal. And so as I said that we have split it into two parts, the movement. So basically in travel wise traversal, what we're doing is that we will go one by one. So basically we will go we will first access a column, then we will go down the column. So basically in this column 0, I will move from row 0 to row 1, then row 3 in this order. Then as I reach the bottom of the column, I will move to the next column, that is column 1. And in the same fashion, I will go from 3 to 6 to 10 to 12, accessing all the elements present in that column from top to bottom. And similarly, I'll go to the second column, then I'll access the elements 5, 9, 14, 13, and I'll do this until the end of the array. So basically, the mechanism that we're going to follow is outer loop selects columns. That is, the outer loop selects which column we are going to iterate in. That is the 0th column, and the inner loop iterates down within the column. So at the 0th column, we will access all the elements present in the row. That is 0, 1, 2, 3, all the elements present in that subsequent rows. And coming to the next type of traversal, that is zigzag traversal. So, what do you guys mean by zigzag traversal? So, basically, an alternating left right and right left movement way of traversing the matrix. So, basically, what I'm going to do is that I'm going to first move left to right. Yeah. Then I'm going to move right to left. Then again, I'm going to move left to right. then again I'm going to move right to left. So basically what we are doing is following a zigzagish pattern. um Let me use a better color. In color, let's use blue. So basically I'm gonna just traverse it like this, left to right. Then for this I'm gonna do right to left, and for the for the second row I'm gonna do left to right, and similarly for the last column I'm gonna do right to left. So this is my zigzag traversal, alternating left and right movements. And coming to the another important traversal, that is spiral or a traversal. So spiral has many types, that is clockwise, anti-clockwise. But at this point, we will just cover what is a clockwise traversal. So basically, what I'm gonna do is I'm gonna go to the first, I mean the zeroth row, access all the elements. Then I'm gonna spiral down the last column, and in the same way I'm gonna spiral down again like this to the last row, and I'm gonna come back and I'll just follow the same pattern. So basically it's spiraling like this. So I'm basically accessing all the elements present at their boundaries. Then I'm gonna go inside the matrix in a spiralish manner. That is completes our spiral order traversal, that is traverse the matrix layer by layer, starting from the outermost, that is the outermost. Then I'm going to go to the innermost. Yeah. So like these are like concise definitions that you guys can keep in your brain, so that it just flashes you whenever someone asks, okay, what kind of traversal that you're gonna do. And coming to diagonal traversal, basically, as I explain later, that we are just gonna access the diagonal elements. And as one of the attendees asked, does the diagonal formula work for a non-square matrix? So this is the prime example where we are gonna get the secondary diagonal elements using that formula, that is this. And that completes moves the matrix diagonally, following the primary and secondary order. Then boundary traversal, as I said, we are just gonna access the elements present at the outermost parts of the matrix, that is basically the topmost row, the bottommost row, the leftmost column, and the rightmost column. And as you guys can see, I have also mentioned the scenarios where you're going to use this traversal. So zigzag is mainly found in pattern matrix printing questions in LeetCode. Then spiral order is found in like there is a special question of spiral order in LeetCode and boundary based questions. Then diagonal, though, you will find everywhere, like for solving a tic tac toe game, or finding elements in a Sudoku, or in chess. Like diagonal traversal is most important out of all the traversals. And boundary is rarely used, but still it's good to keep it in your brains. And coming to the code of row and column traversals. So basically, as I said, in row-wise traversal, you have the outermost follow-up that will access the row, and the innermost and the inner follow for accessing the column. So let's take an example. So basically, I have for outer follow-up that will access the row, then the inner follow-up that will access the column, and I'm gonna print array. I had shown this, guys. I mean, I have shown this previously. That's the reason I'm not gonna cover it once again. So basically, let's do the dry run of the first row at least. So basically, initially my I is zero. That basically means zeroth row, and this inner for loop basically traverses all the elements present at the zeroth row. It starts from one, then moves to, sorry, it starts from zero, then moves to one, and moves to two. So basically, I'm at zeroth index, then I'm at uh, a zeroth column. That is, if I take the analogy of the room, I'm in the ground floor, the first room, the second room, and the third room. So basically, that's our row-wise traversal. And coming to the column-wise traversal, so I have for loop where where this for loop is basically the columns that we are traversing. So it represents the column. So basically, I'll be at zeroth column. then I'll be at first column, then I'll be at second column. And this inner for loop basically traverses through the rows like this. So basically, if we take a dry run, initially my j is equal to 0. That basically means I'm at 0th column, and I have this inner for loop that basically accesses the elements. Basically accesses the row from 0 to 2. So initially, when I'm at j is equal to 0 index, that basically means I'm at the first column, and I'm basically accessing all the elements present in the first column from top to bottom order. So basically, the first element of the column is 7, then the second element is 15, and the third element is 30. And in the same way, after completing this, I will move to my next column, and in the same order, I'll just print the elements, that is 8, 16, and 31. Then I'll move to my last column, that is 10, 20, and 30. So these both are like very simple kind of traversals. And coming to the most important traverse, I mean, not the most important, but uh, one of the important zigzag traversal. So basically, this is the code. While explaining in the diagram, you guys saw that for zigzag traversal, first we will go from left to right, then from right to left, from left to right, from right to left. If you guys were clever enough and had very good observation, you might have already found out that what kind of traversal I am doing, for how I'm gonna, like, how am I judging for what row and for which row I'm going to do which kind of traversal, that is left to right, from right to left. So basically, uh, if I write here 0, 1, 2, 3. So for the 0th row, as I said, we are doing left to right. And for the first row, we are doing from right to left. And for the 0th row, it is left to right. And for the last row, it is right to left. So basically, you guys can see that the pattern is for all the even array, all the even row locations, that is 0, 2, 4, 6, 8, I'm doing left to right traversal. And for all the odd row, all the odd row indices, I'm gonna do left to right traversal. So that's the key in zigzag traversal. So for even indices of the rows, I'm gonna do left to right, and for the odd indices, I'm gonna do right to left. So basically, we have the row, for loop that will access the row, and I have a check that is basically done using for loop, where I'm going to see if my current I is either even or not. If it's even, I'm going to run for loop and do the traversal from left to right. If my current row index is odd, I'm going to basically do right to left traversal. And these are the codes of doing that traversal. Basically, I'm starting at the end of the column, then I'm gonna move right to left, as I showed you guys in this example. So basically, for odd indexes, I'm gonna start from here and go from 9 to 8, 8 to 7, 7 to 6, 6 to 6. So that ends up your zigzag traversal. And coming to one of the most important, the diagonal traversal. So don't worry about this, guys. So basically, just look at this part of the code, where what I'm doing is, let's take, for simplicity, a 3 cross 3 matrix, and let's fill it one. Just write the indexes and let's fill it. So this is 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so I am running a for loop. So basically, this for loops basically helps represents the row. As I said, all the indexes of the primary diagonals are equal, and we have derived a special formula for the secondary diagonals as well. So let's run this for loop one for each case of I, and let's see what we get. So basically, when I is equal to 0, we have mat 0 of 0. So basically, this represents 10. And the secondary diagonal, that is 0. Since I have 3 columns, so it is 3 minus I minus 0. So basically, that's 2. So we have 12. And coming to the next So basically this proves that the formulas that we have derived is actually correct. So the first elements of the primary and the secondary diagonal are 10 and 12 respectively, and that's correct. And let's move I to 1. So I have mat of 1 comma 1, that is 14, and mat of 1 3 minus 1 minus 1, that is again 1, and we have 14 again. And let's run for I is equal to 2. We have mat of 2 comma 2, that gives us 18, and we have mat of or 2 comma 3 comma 1 minus 2, that is basically 0, that gives us 16. So as you guys can see that I have proved that why this formula works, and this accurately gives the elements present at the primary and secondary diagonals. And this is actually like very like one of the most important concepts from the two-dimensional array, since this will be used in solving problems related to Sudoku solver, solving a chessboard, and many other complicated problems. And if you guys understand this concept very well, then you can just solve them in like in a one go. And coming to, yeah, let's have a quick check from you guys that you have understood these concepts. Time complexity, yep, it's correct. It's big O of n square. Guys, do guys? Yep. But actually, it is 1 2 1 2. Is it not? Can you like write your doubt in a more clear way so that I can have a better understanding of what you're asking? Okay, 1 2. Uh, zigzag traversal. Okay, okay. Like let's first clarify the doubt of someone. So basically, what does 1 2 mean? Is it the index positions? Yep, and coming to Shivam, bro. Yes, okay. The first row contains. Okay, okay. 1, 2, 3. Yeah, yeah. So basically, there would be two scenarios in this. Yep. So let's go back to the drawing board again. So you said let's have a matrix like this, right? So I have 1 2 here, and I don't have any third element, and then the second row I have basically like this. Yep. So basically, in this, you can basically have two scenarios. Uh, so am I right that what your doubt is? So basically, if I have a matrix where I have 1 2 and 1 2 3, how will I get the diagonals? That is your question, right? Yeah, it is actually valid. It is completely valid. Basically, there won't be any element. Basically you'll not have any element here, but it's actually valid. Basically, whenever you are making a matrix, you always try to make it in a rectangle, I mean a square matrix, because you can easily traverse, and wherever you don't have any elements, you can just put a like a flag like 0 or something which represents there is nothing. And it's completely valid, but for the sake of ease we always try to go with the square matrix. That's it, but it's completely valid. Does this solve your doubt? Okay, good job. And coming to summer, Pandi, bro, let's go to your doubt. That is zigzag traversal. So basically, can you specify what you didn't understand in zigzag traversal? So basically, how we can do diagonals of this. Yeah. So coming to that part, so basically, I will have two cases. Either I can say that the number of columns from the perspective of the first row, I have only two elements in the column, but in the perspective of the second column, second row, it's three. So if I choose two as my columns, then I will get a diagonal matrix like this. And if I choose a scenario where my columns are three, that is starting from here, then I'll get a diagonal like this. So it basically depends on the scenario. basically, if you want to choose, God, yep. So basically, if you want to choose two, then you will get this as your primary diagonal, and if you want to choose, you get this as your primary diagonal, and it's completely valid. Both are correct in their own view of perspectives, and it depends on the question. You can just use both kind of things based on the question what you get. Does this clear your doubt, Aniket? Yes, sir. Come on, let's go to Shivam Pandey start. Uh, regarding okay. Okay. Come on, let's clarify that doubt. So where is my zigzag traversal? Okay, so let's take an example once again here. Let me just clear the screen for you guys. Yep. So basically, what I said was, so let's have this index as 0, 1, 2, and so let's fill this 15, 18, and 20. This has 1, 2, 3. This has 9, 8, 7. So basically, what I said in zigzag traversal is that first we will access elements from left to right, then we access element from right to left, and again we access elements from left to right. So basically, what I said was, we will start the columns. So I mean, start the rows from I is equal to 0, and whenever we encounter an even row that is either 0th row or 2 or 4 or 6 or so on till any even number, we do the left to right traversal. And to basically, what does I mod 2 basically means that if this number is even or not. So basically, this is the way we check if number is actually even or not. If so basically what this basically does is that like if I have 12 and I do 12 mod 2, basically it says what is the reminder when I do 12 mod 2. So basically the reminder when I divide 12 by 2 is 0. So basically that's the way of checking if indexes is 12 or not. And there is a property that all the even numbers are divisible by 2. So basically this is how I check if the index is even or not. If the row is an even index, then basically I'm gonna do the left to right traversal. So basically, I'll have j is equal to 0, and basically, I'm gonna just print like this. So we'll basically print 15, 18, and 20. And so basically, we are done with the first for loop. And now coming to the second value of I, that is 1. Since what is reminder when I divide 1 by 2, so I'll have reminder of 1, right? So basically, so this condition is false. So that's the reason we will execute this else block. So basically, what I'm going to do is that I'm going to start from this index, that is 2, and I'm going to move right to left. So basically, it will print like this 3, 2, and 1. And this loop is done. Then my new index value is 2. And since reminder when I divide 2 by 2 is 0, so I'll basically run this for loop again from left to right. So I'll get 15, 18, and 20. Uh, did you get what I explained, bro? For zigzag, you must give is. Yeah, it is I. Basically, we are doing zero-based indexing, right? That's the reason it starts with 0. Uh, so that's the reason I is always starting with 0 because we are using zero-based indexing system here. Yep. And coming to Unnati's and Aniket's doubt, but getting address is not possible in that case. Uh, oh, yeah, that's the reason I said here. That's the same reason. Based on what the question asks, you can do this. That's the reason I said we can store it with a zero flag that says that there is no element present here. So basically, that's the whole point of having a square matrix, because it simplifies the process of traversing elements in any order. And as you guys said, if I have 1 and 2 and 1 2 and 3, so basically in ideal scenario I will obviously make a 2 cross 3 matrix, and I'll just say that at this position I'm basically filling it with 0. That basically means that there is nothing. And if I want to do diagonals, so secondary, so in diagonals also, diagonals there are many types. It's not just this, like this is also a diagonal, this is also a diagonal. For each matrix it has a primary and secondary diagonal, and the secondary diagonal basically means the longest diagonal. So in this case of 2 cross 3, this would be a longest diagonal. So it ultimately depends on questions what they're asking. Yeah, so coming to this point, it takes null. So basically, that's the reason we take the highest size. So if you have elements like 1, 2, and 1, 2, 3, we'll take the largest case of 2 cross 3, which row has, which column has the highest number of elements. So basically, we are going to take 2 cross 3. Or, yeah, so is the doubt clear, guys? Unnati and Aniket? Yep. Yeah. And I hope the explanation is understandable to you guys. Can I get the responses? I mean, I can just see like 3 to 4 replying out of the strength of 60. Come on, guys. Stop spamming. I want to see the energy. Come on, come on. I'm just saying this 2, 3 people. Come on, come on. I want to see that you're active and not attending the sake for the. Yes, let's go. Let's go. Let's go. Let's go. Yep. So coming to the applications. So basically, the primary application that we have is maps, that basically you will find is of two-dimensional array and vectors as maps, representing terrains and all using maps. And as you guys will go further in your DSA journey, you will learn a thing called DFS and BFS. That's depth for search and breadth for search. And two-dimensional arrays, very important for that. And if you guys have like completely understood today's session, then you will just it will be a very easy job for understanding those concepts as well. And game boards like chess, Sudoku, like after you guys finish this, you can go to LeetCode and check this Sudoku solver problem, where you will have the ultimate use of 2 cross 2 matrix. Then in image processing also you can find this graph representation and dynamic programming. Like this thing you will not understand now, but as you guys go further in your journey, you will have a very good understanding. And coming to the live problem. So the problem one of today that we're going to solve is a matrix diagonal sum. So what is this question asking us? So let's read it. Given a square matrix mat, return the sum of the matrix diagonals. Only include the sum of all the elements on the primary diagonal and all the elements on the secondary diagonal that are not part of the primary diagonal. Okay, so now let's break down the question. So what, like I'm gonna give you a very nice strategy of solving any lead code questions. So basically, whenever you encounter a question, always split the question into small chunks. So basically, we have a square matrix, then they ask us to return the sum of the diagonals. And there is a small condition that all the elements of the primary diagonal and all the elements of secondary diagonal that are not in the primary diagonal. So I've broken down this question into small chunks. Now let's see what are those chunks are. So basically you're given a n cross n square matrix. So square matrix basically means that the number of rows and columns are equal, and you must calculate the sum of primary and secondary diagonal elements. But there is a small catch. If the there is a small catch. Let's look at with the live example. So this is our primary diagonal, right? So what would be its sum? So it's 1 plus 5 plus 9, so it is 15. And what is the sum of my secondary diagonal? It is 7 plus 5 plus 3, that is again 15. Now if I do the sum finally, my answer is 30. But as you guys can see that 5 is appearing twice, so I don't want this scenario. So what they are basically saying is that whenever we have this intersection element, we need to count it only once. So that means I need to subtract the extra five that have counted and give the answer that is 25. So basically, we need to count this five only once. So basically, that is the meaning of this line. All the elements on the secondary diagonal that are not part of the primary diagonal. So this is what this line means. And coming to the logic, that how we will solve this question is basically we will basically we'll have a for loop that will help us add the primary diagonals like this and add a secondary diagonal like this. And we will have a small if condition that helps us know if basically we are at the intersection. So if we are at the intersection, we will basically subtract that element that we have counted twice. In this case, it was 5. That's the reason I've written -5. Yeah. So basically, let's look at the algorithm that we are gonna follow. So basically, I'll initially have a sum counter that is used to hold the value of my sum, and I'll have a for loop that moves from I0 to n-1, and basically I'm gonna add my elements present at the primary diagonal, and in the same way add the elements present in the secondary diagonal. Now, if I reach the intersection, so this is the line where I'm reaching the intersection of both primary and secondary diagonal. That is this. So whenever I encounter this condition, I'm gonna subtract, because see, whenever I'm gonna encounter this condition, I've added that element twice. So let's take a small example. So let's have this. Let's have 10, 11, 12, 13, 15, 16, 18, 19, and 20. So this is my primary diagonal and this is my secondary diagonal. So let's do a small try run. When I is equal to 0, I'll add, so the elements that would be added to our sum is 10 and 12. And their indexes are, index of 10 is 0 comma 0, and from our formula the index of 12 is 0 comma 2. Now let's come to 15. Basically sum 15, since it is at the intersection, I'm counting it twice. So index of this is 1 comma 1 and index of this is 1 comma 1. So that means for all the intersection elements, their indexes for the primary and secondary diagonals are same. So that is the reason I'm having this small check, basically to check that if I'm at the intersection or not. If I'm at the intersection, then I'm gonna just subtract it, because I've counted it twice, right? In this lines, basically this would be 1 comma 1 and even this will be 1 comma 1. So that means I've added 5 twice, I mean 15 twice in the scenario, and I'm having a small if condition to check if I'm at the intersection. Since I'm at the intersection, I'm just gonna remove the second time that I had added in the sum, and basically that's I'm doing. And coming to the time complexity that you guys have learned recently, so we run a single for loop that is 0 to n-1. That's the reason the time complexity is big of n. And since we are only using the sum, that's basically constant space complexity. So let's quickly code this on our lead code platform. So first question, do you guys have any question? Did you guys understand the logic? Yep. Guys, did you understand the logic of this question? And did you understand the question clearly? Yep. Let's go. Come on, guys. I won't need more responses. Come on. I'm not gonna code until you guys start spamming it. Yes. Okay. Let's go to the question. So basically, this is my lead code interface, and let's code it. So basically, I have int is equal to n mat dot size. So basically, I'm getting the size of the matrix from this line. Okay. Let's write thing size of the matrix. Since it's a square matrix, I'll have row and column is equal, since it's a square matrix. Okay, so basically this will give me that. Then I'll have my counter that is sum is equal to 0. Then I'll have a for loop that will go from I is equal to 0, I less than n, and I plus plus. Then I'm gonna add the sum that is mat I comma I. that is primary diagonal. Then I'm going to add the elements from the secondary diagonal, that is mat I, then n minus I minus 1. Then I'm going to have a small if condition to check if I'm at the index position, I mean at the intersection or not. If I am at the intersection, then I'm going to just subtract it because I've counted that 2 times. And after doing all this, after completing this for loop, I'm just going to return the sum. Okay, so let's run it. Yep. Yep. So it passed all our test cases, and let's finally submit it. Yep. So this how you code it. Do you guys have any doubt in this code? And for your references, I've also put it in the slides. You guys can check it out later after the class. The solution. Oh man, 1 minute. Yep. So you guys can check the solution. That's the same code that I've written. Did you guys understand the solution that I just coded now? Come on, guys. Come on. How's the energy? Yeah. Yep. You guys understood. Okay. Let's go to the second question of the day. So this is the second question. Basically, I'm given a two-dimensional matrix array, and I need to return the transpose. The transpose of the matrix is the matrix flipped over its main diagonal. Yeah, this is too complicated English. So basically, what is happening in transpose is that whatever row I have, basically I'm converting it into a column like this. So this middle row gets converted into a column like this. This last row gets converted to a column like this. So basically, I have a row. I'll turn it by 90 degree and make it a column, and just attach it again. So basically, this is what's happening. This is what's happening in this question. So let's see what the question is asking. We're given a M cross N matrix. So in this case, it's a general matrix and not a square matrix. And we should basically return the transpose. It's very similar to the transpose that you guys have learned it in matrices, just like that. And what is the logic and logic that we are going to basically follow? Transpose changes rows into column. So yeah, the row 0 becomes the column 0, the row 1 becomes the column 1, the row 2 becomes the column 2. That's what I said here. Row 0 becomes the column 1, column 0, the row 1 becomes your column 1, and row 2 becomes your column 2. And coming to the algorithm that we are going to follow. So let m is equal to number of rows and n is equal to number of columns. We will create a new matrix of same dimension n cross m, and we will basically run a for loop for the basically we will run two for loops from I is equal to 0 to n minus 1, and j is equal to 0 to n minus 1. And basically what's happening here is that, okay, let's have a small go through on this. Let's say I have 10, 11, 12, 13, 14, 15, 16, 17, 18. So basically, I'm gonna make a answer vector, two-dimensional vector. So what I'm gonna do is that, so basically I'm gonna access the elements. So let's have a dry run and access all the elements in the 0th row. So index of 10 is 0, 0. And what is the transpose? So basically I'll place here, and I'll have 11, that is 0, 1. So I'm gonna place it here. So you guys can see that this is 0, this is 1, this is again 1, and this is sorry, this is 0, 0, this is 0. So basically what is happening is that I'm just flipping and I'm placing it in the arrow. So 0, so basically the transpose basically means I'm flipping the indexes. So where I had I comma j, basically I'm making it j comma I. That's the whole logic of this question. So then 11 will be placed at 1, 0. So 0, 1 will be placed at 1, 0. Then this is 0, 2, right? 12 is at 0, 2. Basically, it will be placed at 2, 0. So basically, I'm flipping I and j to j and I. That's the whole logic, guys. That's the whole logic of this question. And that is what it's shown in this scenario as well, in this algorithm here. So let's erase this important part. So basically, I'm basically flipping it. That's it. And coming to the time complexity, since we are accessing all the elements of the matrix, all the elements, and this matrix has m cross n elements. That's the reason. So 3 cross 3 is 9. So that's the reason the time complexity is big O of m cross n. And coming to the space complexity, since we are making a new array, right, due to dimensional array of n cross m times. So that's m cross n. That's the reason the space complexity is m cross n. So let's come. Uh, are you guys understanding? Did you guys understand the logic of this question? Let's live code it. Yes, yes. Come on, let's live code it. Yep. So, yep. So basically, let's start it like this. So basically, m is equal to matrix. So size. Then I have n is equal to. Basically, m basically represents the number of rows, and n basically represents the number of columns. So I'm defining a new vector called answer, and as I explained you guys before, that how I can make a vector of the given dimensions using this syntax, and basically I'm gonna run it like this. Then I have another for loop, and j is equal to 0, j less than n, j plus plus. Then I'm just gonna flip, guys. That's it. That's the whole purpose of this. I, comma j, and done. And I'm gonna basically return the new matrix that I've created. That's it. So let's run it. Yep. So my test cases got accepted, and we'll just submit. Yep, and it got submitted. Guys, did you understand the whole live coding? And I have gave the solutions. You can just look at the solution in tomorrow's, like when we're gonna upload the PPT. This is the solution. You can follow it if you get confused. Did you guys get it? Let's have high energy. Let guys respond. Did you guys understand it or not? Spam, spam, spam. Come on. Yeah, that's the energy, guys. Thank you so much. I hope you guys understood all the concepts that I've explained. And now we will move to the quiz section. Yeah. The link will be in the chat soon.